Let's talk a bit about the sum of a geometric progression. Remember the terms of a geometric progression are A, when you have A times R, you multiply by the common ratio R. So A is the first term, you multiply by the common ratio R, you get AR. For the second term, to get the third term, you multiply the second term by R. And you get AR squared. Fourth term, you multiply the third term, AR squared by R. And what you get is AR cubed. You have AR to the fourth and so on. AR to the fifth, right up to AR to the n minus 1. Good. Now, this is the sum of n terms, so let's call it S subscript n equals, and you add all of these together. Alright, let's write this again. So the sum of n terms of a geometric progression is A plus AR plus AR squared plus AR cubed plus AR to the fourth plus AR to the fifth and so on up to AR to the n minus 1. Alright. Suppose you multiply the second sum by R. Multiply this by R. This would become AR plus AR squared plus AR cubed. Alright, so this would be AR cubed, AR to the fourth, AR to the fifth, AR to the sixth, and so on. So you have AR cubed to the 3, to the fourth, to the fifth, AR to the sixth, and going up. What happens when you multiply AR to the n minus 1 by R? Let's see. AR to the n minus 1 times R. R means R to the 1. You remember that when you have a number to a power, times the same number raised to another power, you add the powers. So what you get here is AR to the, when you add the power here, n minus 1 to the power 1, what you have is AR to the n minus 1 plus 1, which is n. Okay, so this becomes AR to the n. Alright, nice. Suppose you subtract these two sums. Let's say you have the top one here minus the bottom one, Sn minus, so you subtract the left hand side, Sn minus R, Sn equals A, all of these, minus everything here, A minus. Now the A plus AR, the AR will subtract from this AR. So these cancel out. AR squared minus AR squared, AR cubed will minus AR cubed, AR to the fourth will minus AR to the fourth, AR to the fifth will minus AR to the fifth. There's going to be an AR to the sixth up here. And it will subtract this AR to the sixth, alright? What would happen here? This stops at AR to the n minus 1. This stops at AR to the n. But before you reach AR to the n, you would have had an AR to the n minus 1. So let us see how that part goes. So this now would have an AR to the n minus 1, then plus an AR to the n. So this AR to the n minus 1 would subtract this AR to the n minus 1. And all of this will minus AR to the n. So you minus AR to the n here. Alright? Now, let us factorize. Put Sn outside the bracket. This is 1 minus R equals, you factorize, you factor out A, and this would be 1 minus R to the n. So what do you get here? What you get is Sn equals a 1 minus r to the power of n divided by 1 minus r. Alright, so what we have here is the sum of the geometric progression. And this is so provided, of course, that r is not equal to 1. Because if r became equal to 1, you would have 1 minus 1 in the denominator and you'd be trying to divide by 0. Because 1 minus 1 is 0. So r cannot be 1. So here we have the formula, this equation that gives you the sum of a geometric progression. Alright, I will see you in the next video.